Hello and welcome to another edition, or the second edition of 10 Buck Test Bench from the actual 10 Buck Test Bench. Today we're going to take a look at a piece of equipment that was just donated to me by a fellow I've mentioned before who wishes to remain nameless. We call him Cubo. He knows who he is. He's donated a Heathkit 10 megahertz dual channel scope. Now, I had this scope in my hands many years ago. I'm trying to remember exactly how long ago it was. However, I'm having, it may have been 10 years, maybe not quite that long ago. I had it in my hands for repair, and at the time I had replaced several of these tantalum capacitors, and there's one with the side blown out of it. I know the lighting's not as good in here as it is in my other lab. Let's see. Maybe we can get some light over here. We have a charred resistor and a blown up tantalum capacitor. These were stuck inside the envelope for the manual when he handed it back to me. So I suspect that I had put all the destroyed parts, or what I could put of destroyed parts, in the book form. This chair is not going to work out. This chair is too creaky. The scope had blown a couple of tantalum capacitors off the board. One of them was nothing but leads and a charred skid mark, and that one had the side of it burned off. The manufacturers tend to use tantalum caps where they need very low ESR and a very small capacitor package. They're a little bit pricey, and they tend to fail with monotonous regularity and fail usually in a most spectacular fashion. Most electrolytics don't go to a dead short, or if they do, it's gradual. They usually just tend to get lower and lower and lower in capacity, where the tantalums tend to go up in flames, which is unfortunate. At any rate, before we get too deeply into this thing today, I figured I'd answer some questions. One of the most common questions I get is, where do I get my hands on all this equipment? And those of you who are regular viewers have, the focus doesn't like to come in too quick on this, does it? A little bit dark in here. We'll have to get some more lighting. Most of this equipment came from the fall flea market this year. I went in with the intent purpose of finding $10 items for this series, and came home literally with a trunk load of goodies. Now, for those of you who aren't ham radio operators, amateur radio operators, do a search in your area for ham radio clubs, amateur radio clubs, amateur radio flea markets, ham fest, any of those keywords. And if you're diligent, and if you look, if you spend a little time, put a little effort in, you're going to find somewhere in your area a local ham radio club. And nearly all of them put on some kind of flea market or ham fest at least once a year. We're very fortunate here in New Hampshire to have Nearfest once in May in the springtime and once in October in the fall. And most of the gear that's on the bench here came from the fall flea market, because I went in with the intent purpose of looking for $10 items for the test bench. And with a little haggling, I came home with a plethora of items. So if you're diligent, and if you go looking and put a little bit of effort in, you'll get some of this gear at a very reasonable price. Now, I'm not saying it's all going to be 100% functional. Example, this Heathkit condenser checker up here on the second shelf. I bought this item. I believe I might have paid, I paid $10 for this one. I paid $15 for the other one, 15 or 20 for the other one, which was, in my opinion, too much money. But I paid $10 for this. It was absolutely filthy. It was covered in so much grunge and dirt you wouldn't believe it. To look at it now, you'd think it just came out of the factory with that shiny faceplate. That was a little bit of application of turtle wax replacement of all the capacitors and a couple of bad resistors, and now I've got a decent piece of test equipment. Which brings up another question that I get fairly often is, how do you learn this stuff? Where do I go to learn this? Same place. Buy some of this older equipment, bring it home, and work on it. Fix it. The manuals for Heathkit or ICO and even a lot of Hewlett-Packard equipment is available free online. In fact, Agilent Hewlett-Packard maintains on their website a database with a lot of their legacy equipment, and it's free for the download. Now, I prefer hard copy manuals, so I've either printed out or purchased the manuals, and typically I'll end up paying more for the manual than I did for the item. Heathkit manuals go for $15 or $20 a piece. But again, it is absolutely free online. You can download it and print out the pertinent pages, and it won't be as pretty, but you'll have the information you need. All of this vintage equipment is going to need the capacitors replaced. All of this vintage equipment is probably going to have 1 or 2 resistors that are out of tolerance. That information is on the schematic. However, once you've cleaned this up, put a little turtle wax on the face of it, use a little Windex or Simple Green or something on the case itself, replace the power cord, you're going to learn how to work on electronic equipment. Start out with the basics. Yes, this is tube gear. So what? Are you such a prima donna that you can't stand having tubes in the shack? This stuff works great. It kept the electronics industry going for many, many, many years and still has many years of useful life left in it. In fact, let's take a look at some of this gear. This is a Hewlett-Packard piece. This is probably, I don't know, 1960s, 1970 vintage. I had to go through the power supply and replace several bad capacitors. However, now I have a useful audio distortion analyzer. That's a very nice piece of gear. This, as we mentioned, I replaced all the capacitors and several resistors. The tubes were fine. Typically, the tubes in this gear are absolutely fine. They typically have few hours on them. And surprisingly, while every shop back in the 50s and 60s had a tube tester in it, tubes typically aren't the problem. It's capacitors and resistors. Down here, this signal generator. I had to make a dial for the face on it. I had to replace some bad capacitors. The tubes were fine. It's up and running. We now have an RF signal generator that works just great. Oh, I had to replace an NE2 lamp and the relaxation oscillator. There's a whole video on that if you don't know what a relaxation oscillator is. This little Heathkit counter down here. That I got in a stack of equipment off of one guy's bench. I got like 6 pieces of gear from him. Averaged $12 a piece. So I paid $12 for that counter. And Mike of Mike's Radio Repair was kind enough to send me a couple of LED segments for that. Thank you, Mike. I know I've said it before, but I really do appreciate it. So now we have a usable frequency counter so we can accurately set our RF generator, signal generator. I picked up this audio generator, sine square audio generator from the same guy that I got the, oh come on Vern. Oh, the same guy I got the frequency counter from and several other pieces of gear. Again, this was a $12 purchase. These go for, on eBay, for $150 to $175. However, if you look around, you can find them for $10, $15, $20. Again, it was filthy. A little bit of Windex, a little bit of Simple Green, half an hour's work, clean the knobs up, replace the capacitors in the power supply for about $4. Bang, you have a nice sine square generator. The solid state voltmeter that's here, again, from the same gentleman. This was a whole stack of equipment. The over here on the side, you've seen the signal tracer. I've done a couple of videos on this guy, and I actually paid too much money for this. I paid for, I think I paid $30 for that, and the reason I did it was just so I could have it on the test bench. I've passed up many of these for $10. In fact, I sold one a couple of years ago for about $39. It was absolutely pristine. And it's just I have so much test gear down on the main bench, down in the main lab, that I was not using this very often. Regretted selling it and picked this one up so I'd have one for the $10 test bench series. Again, went through, changed the capacitors, cleaned it up, did some calibrations, made some improvements. We now have a useful signal tracer on the bench. The dual channel power supply that's down here at the end, this guy over here, and boy, this chair's creaky. I got this, they were selling these for $20. This one had a quote-unquote faulty channel. I paid $10 for it. The switch was dirty. Cleaned up the switch. I now have a nice little dual channel power supply, 0 to 50 volts. This gear is available. This gear is available everywhere. And again, the scope was just donated to me. And thank you, Cubo. We really appreciate that. We will keep this one on the bench until we find one of a little bit more bandwidth. 10 megahertz is a little bit limiting. But if you find one of these at the flea market, a 10 megahertz Heathkit, don't pay more than $10 or $15 for it. And I've said this before. Scopes are $1 a megahertz. Analog scopes without on-screen goodies, on-screen measurements. $1 a megahertz, and in fact I usually get them cheaper. I bought a 30 megahertz 2 years ago for a guy. Guy was asking me for one for his kids. I found a 30 megahertz analog scope, looked brand new. I paid $15 for it. That of course is without the probes. The probes are going to cost you more money usually, unless you get lucky. You never know. I acquired these in a stack of stuff that I bought, so basically I paid nothing for them. But good probes can run you $75 to $100 for something in the 200 to 300 megahertz range. Even more if you buy one of the brand names from like Tektronix or Hewlett Packard. These are Pomona, I think. Yeah, these are Pomona. Not bad probes. So we'll use those with this scope. These are 350 megahertz probes, so they'll be more than adequate for our little 10 megahertz scope here. Again, if you put a little bit of effort in, you're going to find the items, and you'll get them reasonably priced. Another question that I've had on many of them, or many times lately, since we built our 7 transistor radio over here, let me get the light up out of the way. Yeah, come on. Since we've done our 7 transistor radio, and by the way, if you see clothes hanging around the room, it's an effort to get rid of the echoes. I'm hoping that this little experiment by hanging clothes around the room does it, and if it does, I'll buy some tapestries or something to hang on the wall in here to get rid of the echo. I noticed on the last video that there was so much echo I could hear every little smack of my lips, and it was terrible sounding. So we're trying to, keeping the lips drying, we're trying to avoid that on this video, and we are also trying to stop saying "and" so much. Those of you who watch me regularly know I have a real problem with that. At any rate, we built our 7 transistor radio. We covered AM, all the demodulation, how the modulation is done, how the demodulation is done. We went pretty much through this radio. I have since then been given a link by one of my viewers, and I apologize, I can't think of who it is right now, but I'm going to put it down here in the video. When I get back to in front of the computer, I'll get who it was that gave me the idea to go with it. There's another company that makes a 9 transistor AM FM receiver kit, and I was looking over the documentation for it, and let me tell you, they have done a fantastic job of explaining how each stage works, how the FM demodulator works, how the IF section works, how the discriminator works for demodulating the FM. The kit's a little bit pricey. We paid $8 and change for this delivered. This, was like $9. for this kit. And you've also probably seen it in this form, which is in the actual package that it's designed to be in. Nice little learning kit if you want to learn how to align an AM radio. However, this other kit is strictly a breadboard, and I'm going to put an image up here right now. It's strictly a breadboard kit. However, it is well laid out. They explain each and every stage and how this thing works. So we'll go through this one together. We'll build this kit. It's not cheap. It's $39, and it was, I think, $8 to ship it. I don't remember exactly. However, it will make a nice video, or a nice series of videos for the $10 test bench series. We'll build it right here on the bench. And I think my sister's about to open the door. Yeah, maybe she changed her mind. I have my sister for the week. And so she's been out coloring and watching TV. So that's one of the upcoming projects. I also have a lot of parts on order to build my version of the Variac isolation transformer voltmeter wattmeter box. Most people have either a separate, like we have here on the bench, a Variac with a voltmeter, an isolation transformer for working on non-isolated equipment. Buzz, this guy right here, has a wooden box with an amp meter and a voltmeter in it that goes along with his isolation transformer and Variac. I want to build the whole thing into the oscilloscope cabinet that we saved from the burned up oscilloscope. And hopefully we'll be able to get an isolation transformer, some lamps in there to limit current to a safe value if everything goes dead short, a voltmeter, a true watt meter, and an amp meter. And I'm going to try to fit all of that, as well as the Variac and the isolation transformer, into that kit from the burned up oscilloscope, or into that cabinet from the burned up oscilloscope. I was going to do the FM series freelance. Here is, if you really want to know everything there is to know about FM, we have Milton S. Kiver, or is it Kiver? I'm going to pronounce it Kiver. FM Simplified, 3rd edition. Now, FM Simplified. You see how thick this book is across here? This is FM Simplified. And believe me, we go into great detail on FM in this book. And this evidently came from the Manchester Memorial High School. Sold for $6.95. You'd probably pay $30 or $40 for this book today. I was going to freelance it right out of here, and I'm looking for the copyright date on this thing, 1960. Now, of course, none of the theory has changed, but everything in here pertains to vacuum tubes. Not that there's anything wrong with vacuum tubes. Vacuum tubes carried us for many, 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 many years, and a lot of equipment today is still in operation using vacuum tubes. But we're going to try to simplify the simplified when we build that AM/FM kit and explain FM. I was going to do it from this book, and I'm still going to use this for reference material. But going through this would probably be like watching paint dry for people who aren't truly, absolutely interested. We got very lucky with the scope. We have our original Heathkit manual that came with it, as well as all of the schematics that came with it, all of the diagrams. We have all of the documentation for this, as well as another version. This is the manual of operation. This is simply the operation manual. This is the assembly manual. So we have everything for this 10 megahertz scope. We're going to do another video. We'll get into checking this over, repairing it. If it needs repair, he said it last time he plugged it in, it worked. I haven't plugged it in since I brought it home. I'm sure it probably does. We'll do a calibration. We'll show you why 10 megahertz bandwidth is a limitation in compared to something like this thing, which has 60 megahertz of bandwidth. And we'll explain to you what bandwidth means and why it's better to have more. That's another video. Right now, I just wanted to answer some questions, show you what the latest item on the bench was. We'll start cleaning this up. We'll do a video on what we find inside and what we've done to align it, and we'll add it to our collection of $10 or free quote-unquote items. So again, thanks Cubo, appreciate it. Again, thanks Mike for the donation of the LED display that brought that Heathkit back to full functionality. And we will try to get a video up very quickly right after this one. In fact, I'm planning on doing this weekend and the next probably tomorrow. I've got Monday off from my main job, so I've got this is New Year's. I'm doing this right now, New Year's Eve, excuse me. So I've got Sunday and Monday to do a video on this and get this up on the YouTube channel. There was something else. Oh, yeah, we had a very nice storm here the other night. For those of you who aren't from an area where you get a lot of snow, this picture was taken somewhere around midnight with a 13-second time exposure. And this is just the snow clinging to the guy wires of the tower and to my ladder line that goes up to my 160-meter dipole, which is about 100 feet up in the trees. I use a crossbow to put it way up there. But you can see my ladder line is completely encased in snow, as are my guy wires. And you can see the tree over there to the right-hand side of this photo that's been brought down to the ground by the weight of the snow. This was a pretty heavy, wet snow. And this photo is the next morning. We have the antennas up on top of the tower, and the tower itself completely encased in snow. My little GPS antenna up there has a pile of snow on top of it, and that's a pointed cone, but the snow stuck pretty well to it and put quite a top hat of snow on it. And believe it or not, it's very, very hard to get an idea of scale here. The top antenna up there is at the 85-foot level, and the longest element on that bottom beam is about 32.5, 33 feet. That's a TH11, and the rear element is over 32 feet in length. So that gives you some kind of idea of the scale of how high that antenna actually is. It just doesn't look it in this view. That's it for now. I'm the Radio Mechanic. Thanks for stopping by, and thanks for all my subscribers out there having a little bit of patience. The job's been keeping me busy. We're going to try much harder to get these videos out in a more timely fashion. One of the problems is I have a ton of parts on order, a ton of items coming in, and I've kind of been waiting for all of that stuff to arrive, and then we've got some projects to do. For now, I'm the Radio Mechanic. See you soon. Bye.